Here is an example of a kind of question that could be a question 1 difficulty on an AMC 10 type of test. I want to use this as an opportunity to share with you what the difficulty level of such an exam would be, but I also want to share with you some interesting mathematics. So although this question is inspired by an AMC 10 question number 1, there's something in it that shares both some interesting math and maybe a little bit of culture of what people do with pizza in the West. Suppose you have a party of 11 people who have shared pizzas, and the pizzas came with 10 slices each. Each person ate 3 or 4 slices, and they finished all of the pizza. How many people ate 4 slices? In America, it's actually quite common to have these things called pizza parties, where you have many people coming together and the food that they eat is just pizza. Also, if you go to these pizza parties, you often notice that these big pizzas have 10 slices each. Do you know why it's an even number of slices? It's because it's usually easier to cut the pizza to have an even number of slices. But I'll tell you a bit more about that at the end. This now is a number theory problem. When I say number theory, what I mean is that they finished all of the pizza, and the pizzas had 10 slices each. And so the total number of slices has to be a multiple of 10. Now the question is, if I eat 3 or 4 slices each, and I have 11 people, how many people are there that eat 4 slices if I want to have a multiple of 10? I want to talk about different ways to do the same question, not because one of them is just faster than the other, but because a good way to be sure that you have an answer is when you have 2 ways that come to the same answer. Okay, the first way I want to say is that each person eats 3 or 4 slices. So, if I have 11 people, all 3 slices, then that means 33 total slices. On the other hand, if I have 11 people, all 4 slices, then that means in total that they will eat 44 slices. So from this, I know that the number of slices being eaten is somewhere between 33 and 44. Okay, so from this I know that the number of slices eaten is somewhere between 33 and 44. But it's supposed to be a multiple of 10. Since it's supposed to be a multiple of 10, that means that it has to be 40, because that's the only multiple of 10 in that range. Okay? This method works for these numbers because this range has only one number, which is a multiple of 10. I'll talk a little bit more about that later too. All right. So now what do I know? Actually, it looks to me like a similar kind of problem that maybe talks about the number of heads and feet in a farm. What I mean is, you have 11 people, each eating 3 or 4 slices, and they ate 40 in total. And usually the way that you do a question like that is you say, well, pretend that all of the people ate 3 slices. If I want to finish now, what I want to say is that there are 40 slices eaten. And if all of the 11 people ate 3 slices, you have 33. But since if I want to change a person from 3 to 4 slices, that gives you a +1 as a slice, as the number of slices eaten. And so, since I know that I want to go all the way to 40 slices eaten, I need to go by +7, and so that tells me that the number of people who ate 4 slices is 7. Okay, so that's one way of doing this, where we turn the question into this familiar type of problem where I have a number of people eating different numbers of things and a total number eaten. But that also suggests another way you can do it directly, just by doing this idea. And that way is actually very useful because sometimes the question is not so easy like this. First, what I want to show is that the same kind of thinking is that if all 11 people ate 3 slices and each one does a +1, the idea that I need to make a multiple of 10. But this way of doing the problem, where we think of how many you start with and how much each one changes, gives us a more direct way of doing the whole problem. It's a generalization of this old method you're used to with the heads and the feet. You see, I can go straight from saying if all of the 11 people ate 3 slices, there were 33 slices eaten. And now instead of saying I want to go to 40, where the 40 was decided by the multiple of 10 in this range, I don't do that. Instead I say each one gives me by +1, and I want to know what I add to get to a multiple of 10. And that is easy. From 33 to a multiple of 10, going by +1s, is 7 of them. It may seem at first that that's just the same thing. But now I want to show another version of this, where it's actually then very important to go in this way instead. And that's if we change the problem very slightly. What if instead of saying that each person ate only 3 or 4 slices, what if we make it something like each person ate either 3 or 5 slices? Let's choose 3 or 5 slices. We're going to start changing this number. And you will see that at a certain value, it actually becomes such that we can't have just done it the other way. For example, if it's 3 or 5 slices, now what is happening is that if I was looking at here, it was 3 slices or 4 slices. If this one became 5 slices, now I have 55 total. And now the range goes from 33 to 55. In this particular case, this means that it could either be 40 or 50 in the middle. Now, if we wanted to have 40 or 50 in the middle, actually, this is going to tell you that there's a very interesting outcome here, which is the number theory that I'm talking about. This thing tells you if this was a 5 and this was a 55, those would be 40 or 50. So then you would go ahead and try to solve the problem. And what you would find out is you'd find a big problem. You would actually see that if this was supposed to be 3 goes to 5, this would go by +2. Okay? And you're supposed to either go to 40, which is a +17, or you're supposed to go to 50, which would be a this is a +7, or to a 50, which is a +17. So now let me ask you, how many people ate 5 slices if I need to go to either a 40 or 50? This is why number theory is interesting. The answer is it's actually impossible, because both 7 and 17 are odd, and you're going by 2s. But if we had done the other way of thinking, of just starting with the 33 and seeing how many 2s you need to add before you get a multiple of 10, you would immediately know it's impossible. Because you started with an odd number, and adding the 2s, you'd always stay odd. So I'm showing why this second way of doing it, for this number theory problem, is actually the most efficient way to do it. Because then you avoid the problem of finding something in the middle, which you can't do anyway. So this shows you how you can find out how to split the pizza. Maybe a little bit more about pizza. Actually, whenever you go to a pizza party, oftentimes you think about how to share all of the pizza that you're having. An interesting puzzle that I'll leave for you is something that you may have noticed. If you go to a pizza party, and there's some number of people who are there. Maybe you have 40 slices of pizza. Maybe you have 9 people. Even though 9 is not a factor of 40, whenever you go there, if everyone is eating about the same number of slices of pizza, meaning within one of each other, then there's only one way to do this. And this is what one notices whenever you're sharing pizza. That particular fact is related to the remainder when you do a division algorithm. But in the end, pizza is an interesting way to talk about these ideas of division and number theory. And this now generalizes this usual method that you use when counting heads and feet in the land of number theory.